Hey everybody. So in the last video we talked about transformers. In this video I wanted to talk about, I did mention variacs. So in this video I want to talk about what a variac is and how it works as well. So let's get into it. So this is I have two variacs. This is my big one. So this can output 10 amps. This one can output 10 amps. So variacs are fairly simple. On mine, they're going to be different on all of them. Mine, this is custom. I made this myself. But we have our main power here, and then I have this switch which allows us to select a load. So I have these binding post terminals or an outlet on the side here, right there. Usually there's a cover on that, but in order to take this thing apart so I can show you how it works, I took that off. Anyway, once we have our load selected and we have it powered on, we can turn this knob and we can power a load. Let's look at that on an oscilloscope real quick. Okay, so I have a fan here off to the side. We're going to put the fan on its highest setting, as that way not to mess up the motor. Okay, now going to increase the voltage. You can see the amplitude rising, and you'll start to hear the fan. So, as you can see, we have our waveform. We'll make that a little bit bigger, so you can see that a little bit better. I'll zoom in. That's even better. So there we go. And then if we're just adjusting the amplitude and thus the voltage with the variac, which is really cool. And it's excellent for controlling things like fans, or especially for me doing things like electronics experiments. But it's also good if you wanted to like current limit a welder or something like that. So there you go. Yeah, that's the basic premise of what this does. Okay, now let's get into how it works. So like I said, we have this knob on the top here. So let's dig a little deeper. Okay, now let's remove the top. This is what we're left with, the reveal here. So what we have is, as you can see, we have, let me get this cord out of the way here. We have a round core, and we have all of these little windings. Each of these windings represents 1 volt on the output. If I remove this plastic cover right here, it's going to be a little bit hard to see. I'll zoom in as much as I can. Right there, we're going to have a carbon brush that moves across all the tops of these windings. And every one that it touches, right now we're at 0 volts. As we raise that up, we go up to, out of a variac, we can get, I think it's 10% over. So we can get 145 volts out of this rather than 120. Maybe that's 15%, I don't know. But anyway, we can go a little bit over what our output voltage is. And then there's another way we can configure it to get double, or what the maximum, in the case for the US, it's what the maximum voltage is for the AC output of the grid, the AC output is 170 volts. So yeah, if we can figure it another way, maybe I'll show it in this video, maybe I won't, I don't know. Anyway, so that's how that works. But there's something special about this transformer. So what's special about it is this is called an auto transformer. In fact, Variac is an old brand name. I don't know if the company's even around anymore, but it's yeah, it's an old brand name. This is called a yeah, that Variac is an old brand name, but that's just what a lot of people call it. Anyway, what the technical term for this is a variable auto transformer. So what makes an auto transformer special as opposed to a regular transformer, I will draw this for you. We have our so a regular transformer looks like that as a schematic, and it is completely isolated. Both windings are completely isolated from each other. They do not touch or connect in any way. The only way they connect is through magnetic fields. Now this Variac has a different diagram of what this looks like, and I will show that to you. So this is the wiring diagram of the Variac compared to this. You can see we only have one coil. So, yeah, we only have one coil here. And so these are two different ones. This is the one that's represented on my Variac, and then this is the one that's more common. 2 is where our neutral goes in, or 0 volts, or whatever you want to call it. 3 is the wiper, or the variable voltage output. So we'll represent that by V, I don't know. Variable output. Okay. 1 we leave alone, usually. And then 5 is where we would inject our live. 4 is the overwind. So this portion here is the overwind, and that's 120 to 145. And then, yeah, so then that's how that works. Now here's the thing about the Variac, why sometimes it's not the sometimes they're not the safest thing, especially if you're trying to touch it because you think that it's low voltage. They're not isolated from the mains. They're still there, so you still have to be careful in that fact. But yeah, it's not as dangerous as if you were touching directly mains. But yeah, you still have to be careful. So that's why that's what makes this special, is it's an auto transformer, so it has only the one winding instead of 2, so it's not isolated. But it can still, but it's still magnetized. It's like this toroidal transformer. This toroidal transformer has these 2 windings and then an iron core. This also has an iron core. Hold it in the frame here. This also has an iron core, and it's pretty much a toroidal transformer, but it only has 1 winding on it. And then we can just pull whatever voltages we want from the top with the wiper. Yeah, that makes it pretty cool. And then, let's see, what else is good to know about this? You can see that's the general premise of how it works. You can see in here, this is no longer active. That was a bridge rectifier that blew up. Here, let me zoom in a little bit more for you guys. So, these are gone. That was a bridge rectifier that no longer exists. This, I don't know if you're going to be able to see that. This is a CT or current transformer for the readout here. And then the voltage is connected just like a regular voltmeter to this. But yeah, this is the CT, so that's how it measures current. Sometimes to measure current, we can either use a CT like this, current transformer, or we can use a current shunt, which is a resistor in series with the load, and we measure the voltage across that, and depending on the resistance of the shunt, we can tell what the current is. We can tell what the current is based on reading the voltage off of it because of Ohm's law. In addition to that, in this one we have two fuses, or two 10 amp breakers. I mean, not fuses. They could be fuses, but I pop them all the time, so there's no point in having fuses. Put in breakers. So we have two 10 amp breakers. We have one that's on the input and one that's on the output. Generally, in commercial variacs, you only have one on the input, but if you want to be safe, you should put one on the output, just to make sure that if you do end up pulling too much current, you don't mess up your windings and have them melt and all that. This variac is in very good condition, and it's pretty old. It belonged to my grandfather before it was mine, and so it's it's pretty old. These are no longer made. This is made by a company called Superior Electric. Superior Electric, I don't believe that they're still in business, and I believe that they outsourced these to another extremely high-end company. So they made Superior outsourced these variacs to particularly, I think they're smaller ones, they outsource to another company that makes very high-end equipment. Superior Electric is a transformer company, so but yeah, I don't believe that they're still in business. I don't know, I'd have to check. But anyway, you can't buy these anymore. If you wanted to buy one, you're gonna pay like $800 to $900 for one of these, which is crazy. Even my small one, this is a 10 amp, so this is really expensive in that comparison. And then I have a 3.5 amp one, which is like $300. So yeah, not cheap. But you can buy new ones. You can buy new ones. I just don't think they're the same quality as these. But yeah, definitely a really nice way to step up and step down AC voltage if you want to feed it into transformers or control the speed of a fan or dim a light bulb or whatever you want to do. It's a very, 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 very useful piece of equipment. And I would highly recommend getting one if you don't have one. You can buy just a cheap, 5 amp one that'll usually do everything you're going to try to do with it. It'd be hard for me to list off everything that I've used this for. I've used it to dim lights. I've used it to I've used it to like slow down or speed up the speed on a fan. I've used it to control a spot welder, the power that a spot welder outputs. I've used it to control other transformers so that I can better regulate the voltage. I've used it to test low voltage lighting. There's a ton of uses for this thing, so I would highly recommend one. I hope that's a pretty good understanding of how this works with its I hope that that's a good understanding of how it all works. There's one video that I could probably point you towards that would better explain it than I do, but and that's by photonic induction. So I will try to link that. But yeah, these things are definitely great, and I would highly recommend getting one. If you guys have any questions, put them down in the comments. With that, I'll see you guys another day.